Good morning, Kyle. Today we are going to solve exercise 3.22 from the book Fundamentals of Sadiku Electric Circuit. In this exercise I am asked to determine the tensions B1 and B2 by applying node analysis. The first thing we are going to do is a visual analysis of the direction of the currents. Later we apply the annual analysis. If I observe this tension of 2 euros, it generates an upward force due to polarity. So, the first equator that comes to mind is the one that comes this way and goes through this 2 ohm resistor. This current that comes this way, enters this point, has to find its way to another side. One of those paths are those amperes that they say come from here, another, I suppose it comes in this direction. I say it because of this point of land that is here, and the other current I suppose goes in this field. They are assumptions that we make based on what we see, but after we do the analysis we see the exact direction of the current. So, at this point here, this current comes in, that comes from here, this one that comes from here, and enters this point, and is added to the 3 amperes and has to take its way to the other side. If you look at this dependent voltage source, it says 5 times 0, it tells me that the force is making it downwards. I would place it, then the direction of the current comes from here. Now that the direction of the currents has been demarcated, you are left with me, give them names. I'm going to call this current I1. I'm going to call this current I2. I'm going to call this current I3, that is, but this is the same current I3, over here, and this last one I'm calling her by the I4. Now, having those currents marked, what remains for me to do the annual analysis? Tell me here. I will say that in node B1, I am going to mark the currents that enter, they will be equal to the currents that leave. I observe that the currents that enter at this point are I1 and the currents that leave are I2, I3 and 3 amperes. But what comes out from here, that is, at this point what comes out, which are these 3, is the I2 and 2 plus the I3 plus the 3 amperes. It will be equal to the current I1. Yeah, what comes out will be equal to what comes in, the law of 48. Now, the I2, referred to here, was the tension B1 over 4. It would be B1 over 4, yes? This is 0. The attention here is 0, plus the current I3 and the current I3 would be, since the current has this direction, it would be B1 minus B 2 over 8, plus the 3 amperes will be equal to current N1. The current Y1, let's notice that the voltage B2 is exerting a downward force, okay? Due to the direction of current and in the voltage B. This dependent voltage that is here, well, also, oh, no, it is from the I1. The I1 is the one that comes from here. I'm wrong, it's a shame. This is it, right? We are doing the analysis in B1, where the ones come out, they are these, this one comes out, this one comes out, this one comes out, and the one that comes in is the I1. I was looking at I4. The I1 is this. There is a 90 here. Since it has this address, it means that the 2 exhaust greater than B1, yes? So it would be 12 minus B1 over 2 ohms. Ready. Now I don't have to explain something to you. I'm going to say that B1 over 4 plus B1 over 8 minus B 2 over 8 plus 3, well, 12 over 2 would be 6 minus B1 over 2. Well, everything that has a variable on one side is going to be passed to whatever is a constant on the other side. So I'm going to have B1 over 4 plus B1 over 8 plus B1 P1 over 2. Where does this come from? It comes from this thing that is here. I passed it to the other side, so that in case it is not positive I put it on B1, at once to put them together. And lastly, minus B2 over 8. It is equal to 6. This is equity tick, and I pass this to the other side with a negative sign. It would be minus 3. So if I operate all of this, it's going to give me 7 over 8 of the P1 minus B 2 over 8 equals 3. I multiply this by 8. It has to be this by 8 and this by 8. Get that equation 1 would be 7b1 minus b2, okay? Equals 24. That would be our question. I'm going to delete this one. I'm going to analyze now B2. In node B2, that is, now at this point, we observe that here the amperes and the I3 come in and the I4 comes out. So at this point it would be I3 plus the 3 amperes is going to equal the current I4. Yeah? What comes in here? What comes in will be the same as what comes out. So, the I3 is P1 minus P2 over 8 plus the 3 amperes equal to the I4 and the I4 which now does come down here. So the voltage B2 makes a downward force, live by the direction of the current, and the 5B sub 0 is also making a force downward. So it would be B2 plus 5 versus 0. All this about 1. Well, we need to know who sees your 0. Before we do after, let's operate this equation. I'm going to say that P1 over 8 double 8 minus B2 double 8 plus 3 is equal to B2 plus 5 times now, who is wait out. Well, first let's pass all the variables to the other appropriate side. We're here. I have to P1 over 8 minus B2 over 8. This is here to happen now with a negative sign minus B2 minus 5B sub 0. 2 equals negative 3. Now, who is B sub 0? B sub 0 is the voltage that is here. Let's note that not the brand here. And BC0 is the polarity. It is the voltage that drops across this resistor. So how do we know what the voltage drops across that resistor? Let's note that for us to pay attention here, voltage that is equal to current times resistance. So current is equal to voltage over resistance. So, the current that circulates here, as it comes in this direction, well, we already know that it is 12. 2 minus P1 on both shoulders. All this is being this. No, what a pity, it's all this. All this is this, okay? Because what is above is the tension and what is below is the resistance. So, the current that passes through this resistance, what is here, represents the I1, the current that passes through this resistance. But for me to determine the voltage, it has to be multiplied by the same resistance. Yeah, because? Let's see if I explain myself well. I have to find the voltage across this resistor, and the voltage is current times resistance, but the current is 12 volts minus the voltage versus 1/2 voltage. Voltage over resistance is current. So voltage 12 minus versus 1/2 gives me the current. What is here is the current that is here. 12 minus B1 is B and 2 close. But this is current. I need voltage. To have voltage I have to multiply it by the resistance. The resistance, then, remains the same 2 ohms. So, I have to multiply by 2 again. This cancels it out. So we observe that the voltage of sub-0, only 12 minus P1. Already having that F sub-0, I simply replace it here. So, I'm going to leave a little bit. The pot is B1 over 8 minus B2 over 8 minus P2, okay? I'm writing down this and this. I have -5 and B sub-0, which would be 12 minus B1 equals -3. Okay, now, I'm going to multiply this, not by this terminal term, and I'm going to have that P1 over 8 minus B2 over 8 minus B. 2 minus 5 times 2 is 60. And I at least would be more. Five. Bu equal to -3. Now, everything that has B1 is added up. It's going to be 41 over 8 B1. Everything that B has 2 would be -9/8. 9/8, 9 of B2. All of this equals -3 plus 60. Pass this -60 to the other side, it's the same. Now, -3 plus 60 gives me +57. Well, it was multiplied by 8 to eliminate the denominator. I will have 41, P1 minus 9, B2, all of that will be equal to 456. Of equation 2. This would be my equation number 2. I can delete this now, I don't need it anymore. And I'm going to put these equations, 7 minus 1 here, and I'm going to put 7. Well, I'm going to delete this first, and here in the matrix A it would be 7 space minus 1, and 4 minus 9. I put a dot and a comma to go to the next row. So it would be 41. It's 41 minus 9. (41 space minus 9). On the other hand, I have 24 and 450 and 24 point and colon 4. Good. I checked there. Okay. 24,450. The variable is equal to control the B. And here they tell me that there is an error on line 5. Somewhere I made a mistake using control. I'm going to delete here. The error continues to appear. Additional 7 minus equation 1 is 7 minus 1 and 41 minus 9 is equation 2. Here I put 24. It's 40. Oh, no. This one, 49. 49 is good and 24,456. Right here. 24,456. So that there would be no error. You keep scheduling me. It tells me dimension matrix. I understand correctly. Matrix A. Now notice the error. It's good that these things happen sometimes. These are simple mistakes. Notice that the matrix A. Well, I'm printing it. Yes, that's why I didn't put a semicolon. The matrix A gives me a single mention, but it's because they just put a semicolon that you were calm. It had to be a semicolon, an error, and that's it. Ready. So, this is the solution. Minus 10.90 and minus 100.36. So, B1 is equal to negative 10.90 times 3, and B2 is equal to negative 100.30, and those are the lessons B universes. That the ERC asks of us. See you in the next one. Following.